My first time in Romania. Lovely to be here. It is, even the weather outside is beautiful. Look at this awesome fighter jet slide, huh? PowerPoint has a feature called Pimp My Slide, or actually it might be design suggestion or something like that, but basically you click that button, magic happens, and how I get airplanes. My talk is on when an alert is an opportunity. I am not a blue team person, although I've done a little bit of that as well. I'm a red team, and an alert for me, for my SOC, is basically, hey, potential hacking of a customer. The alerts are my opportunities. So quickly, my name is Chris Dale, and I present at SANS. I run my own company. There's an alphabet soup of certifications and so on, and I did get a lovely introduction already, so I'm not going to spend time on that. Basically, my skill sets is within pen testing. I show how criminals break in or threat actors break in, and I help kick them out again, incident response, when those things happen. So, think about this question. Why do we do penetration testing? What's the goal of a pen test? Right? Really simple, dumb question. What's the point of asking for a pen test? Say once a year. Is it so that the CISO can say, are we there yet? And if the pen test findings are resolved, there are things to be concerned about? Is it so that you can fix and patch in the short term? Is it so that you can have long-term security advantages to help the security posture of your company become more resilient? Pen testing in its own very often is a snapshot in time what the scope of the pen test, the security, what it currently looks like, and it's a once a year, once a quarter. It's very often just a snapshot in time. What happens tomorrow after the pen test? You just received a pen test, the CISO is happy, yeah. Tomorrow, Log4j happens. Tomorrow, the engineer, Bob, reconfigures the firewall. Tomorrow, they released a new service. Tomorrow, OpenSSL, there's a critical bug. Pen testing is anything but agile. It is anti-agile. Developers are agile, operations are agile, but what the hell happened to pen testing? Bug bounty is the closest that we're getting to agile currently, and I'm proposing some new ideas and models that will basically help us do more agile pen testing. There are some common problems as getting a pen test and delivering a pen test. So I've worked as a couple of years as a CISO, and I've for many years provided pen tests. And when I was a CISO, I had to go buy pen tests from other companies. And my question was always, what should I put in the scope? What should I ask them to pen test? And it's not, I might not be the best person to know how a hacker thinks, where a hacker might break in. So to be honest, the customer, the client, the ones procuring pen tests, they are not, in my honest opinion, they're not skilled enough, they're not good enough to know what they should have a pen test on. Anybody heard of shadow IT? By definition, the CISO will never ask for a pen test on shadow IT because they don't know about that IT. Also, in my experience, when I do incident response, which is sadly a lot, that's why I get gray hairs, I shave all my sides now, get rid of all the white hairs. When I do incident response, very rarely is the incidents happening on the front chest of the customer. It's not on their front websites, it's not on the systems they knew about. Whenever a customer gets hacked, it's on those systems that they go like, oh no, that system, that old one, the one that they forgot, the one that they didn't have under governance. Hence, pen testing very often pen tests the things that they know about and you don't get a good, complete picture. When I provide a pen test, I have to be contained within a scope, right? So the customers will tell me, maybe I propose the scope to them, then we begin the pen testing on systems A, B, and C, and while I'm pen testing, I'm like, hackety hack, and all of a sudden, I see another system on the side, somewhere, maybe some old PHP application, and I start to drool. I'm like, whoa, that's where I want to hack, but they won't let me, right? I could go back to my customer, and I can say, hey, we found this other system, actually, we want to hack this system, and the customer will not be disappointed because that's scope creep, and they're going to have to put more money on the engagement. So there's all these challenges within a traditional pen test. And let me ask the question, does an attacker care about the scope? Hell no, right? And we must do our best to mimic attackers. We must do our best to do what attackers do to be relevant in this industry. Otherwise, penetration testing will not offer the good value that we should be giving to our customers. There is this hilarious video on YouTube I really want to quickly show you and narrate to you. It is awesome. It's the CISO versus the pen tester. Let's see if I can bring that in here. You see, that's why I see, and some people are laughing already. It is hilarious, right? I'll narrate it. CISO hands the pen tester a gun, and he says, shoot me. Really? Shoot me? Come on, hit me, bro, hit me. Pen tester says, oh, no, that's dangerous, man. Come on, I'm ready for you. Pen tester says, all right, let's have a go at this pen test, man. Shoots him in the foot. That is how I find pen testing
6 av 10
to be in very many cases. So early on, many years ago, I came up with a proposed solution that I've spoken about on conferences here and there, and I've been delivering to customers for a while now. It's the digital footprint assessment. When a customer asks for a pen test, when they come to you and say, we want a pen test, you tell them, no, you don't. You don't want to spend money on a pen test because, well, you don't know what the scope is. Yeah, we do. We want these applications to be, well, that's not where we're going to break in if we're really going to break in. In fact, you tell your customers, you want a pen test? Okay, but first, let us do a small engagement where we do reconnaissance, scanning, and discovery of assets. Let's first go back to our hacker roots and do what we're supposed to do. We're supposed to discover our targets. We're supposed to figure out what the lay of the land is. And we'll present our findings by just looking at the customer. We're not hacking yet. By just looking at our target, we will present our findings in a report that we call a digital footprint report, for example. A digital footprint. What do you look like online? And in this report, we will give our target a prioritized list of assets. These are the ones that are attractive to my team. These are the ones that makes Chris drool. This is a 10. I really want to pen test this target. So why let me? Why don't you remove that target? If I can show you that this target is super attractive to hack because it has old components, because it looks very hackable, you know that hacker hunch that you get sometimes? Yeah, I can probably hack this one. When you have that hunch, why let that system be pen tested? Why not just deal with it in advance? Provide value by just looking. In so many cases, by just Google dorking, by searching via search engines, we can prove to a customer that they're vulnerable to certain things. Finding copies of SQL databases and all kinds of things by just doing reconnaissance. And we should, in advance, provide this value of credential leaks to be stuffed, of targets, lists of IP addresses, social media accounts, whatever it might be, put that in a report so that the customers know what could be in the scope of a pen test and what you suggest, and most importantly, what they don't put in a scope of a pen test. Show them what was left out so that you can take a concise and actionable decision on what to leave out of the pen test and what to actually have pen test. This, in my opinion, has made the life for the customers much easier, and it's also made it much more fun and stimulating to work on pen testing engagements because we've kind of done our job already doing recon and discovery. In short, it boils down to these 3 points. Know the target. That's what we should do as pen testers. We should know who we're targeting. Find as much value as you can by using OSINT, by using APIs, by using your hacker senses, scan, discover. You don't need to exploit and verify those exploits just yet. Let's provide as much value as we can earlier in the engagement for less money, and let the customers essentially know themselves. So this idea is quite nice. And it brings in a topic called attack surface management, which is where the offensive security operations operate. Attack surface management is taking the idea of recon, discovery and scanning, and automating those processes and collecting information continuously, allowing us to see the delta, what changes on a customer's digital IT footprint from one day to another. If you look at pen test methodology, what pen testers should be doing is they should be doing recon, scanning discovery, and exploitation in their engagements. But I am sure that many of you can say and attest for that pen testing in the last few years has revolved a lot around discovery and scanning, and mostly on exploitation and verification. It hasn't focused on recon, and it hasn't really focused on aiming broad. It's been very narrow, very specific and targeted on what the customer wants or what you figured out during a scoping meeting and so on. So attack surface management is basically helping us to automate knowing ourselves and figuring out what there is to pen test. So from one iteration of a scan or one data collection point to another, we can always discover and see what's new, what changed, which ports are open from one day to another. To be successful in hacking and in bug bounty programs and so on, it often comes down to which team has the best recon process. I've always said it to my teams, or when I'm lecturing for SANS, the most important phase of a pen test is not the exploit phase. In fact, the phase that determines our success is the recon. You do a good job on reconnaissance, and you can be certain that you're gonna go break into something interesting. And recon, if you're good at recon, it allows you to find what we call the path or the road less traveled. Those systems that nobody else found. Nobody else has been here in a while. They're old, they're unpatched, they're unmanaged, ungoverned. There might be juice, interesting things in them. And to find the path least traveled, you need to have a good recon, and it often comes down to process. What tools and capabilities does your team use? How well are their word lists? How nice, how well do they know their target? How much information do you have on them so that you can discover more assets and other interesting parts of their infrastructure? And the teams that can find the most interesting parts, they're the ones who get the bug bounty, they're the ones who get in. You know, the NSA, their chief tailored access operator, the guy in charge of breaking into other countries, right? Rob Royce, he held a presentation over on Usenix conference many years ago, and he had a presentation on how to protect yourself against the NSA. The big bad wolves of the internet, kind of, right? They're revered, respected, notorious. Lots of elite hackers in the NSA. How do you protect against them, though? Well, he went through many great points in his presentation, and he told us, as an APT, we don't have to be very much advanced necessarily. We just have to be damn persistent. In fact, when we're done with our targets, we know the target better than they know themselves. Imagine that. Knowing more of an IT network than the IT guys themselves. That's our job as pen testers, but we seem to forget it. So it boils down, again, to recon, having good systems to provide you valuable data to use in your tools and techniques to find interesting systems. There's also a dilemma in today's world. Our organizations that we work for, most of them want rapid changes. They want more with less. They want to deploy, deploy, deploy. They have something shiny, they want to show it to the world. They want to innovate, and they want to grow. IT, security, they want to contain, govern, slow. They want to verify, ensure, and make sure that we deploy trusted things. Those two things work against each other, and attack surface management helps bridge the gap. We're kind of acknowledging that shadow IT, and we're acknowledging that dark data and unmanaged, ungoverned changes are going to happen. We're planning for it, and we want to see it before anybody else does with attack surface management. So it's a nice bridge to allow us to, well, control our assets better and know ourselves more continuously. And that brings us into what I have called always-on pen testing. Because if you have attack surface management, that's basically discovery. That's basically asset management. It allows you to keep on checking, is my logo being abused somewhere? Is there any new ports open on my services, etc.? But always-on pen testing takes in the third part of the process into the equation. We're now saying any new change, any delta, any new credential leak, any port that is open whatsoever, assign that task to a pen tester. Instead of doing a pen test for a week, no, we're going to do a micro pen test on a single port, on a single application, on a new update, whatever it might be, verify this CVE, understand this vulnerability management information, where you're talking about micro engagements that are talking about minutes and hours, not days, weeks, or months of engagement times. So the always-on pen testing kind of brings agility into pen testing world. If we can get customers to pay for it, that is. But yeah, some are, especially the forward-leaning CISOs that realize that, are we hacked yet? Are they already in? Probably. Those types of CISOs, they're willing to pay for such a service like this, where they make a contract with a pen testing company and they say, we don't want to hire you for an engagement, we want to hire you for a year. Let's see what you can do in a year. Be our criminal best friends on the internet, except you're not criminals, we're hiring you through a contract. What can you do as an APT? What can you do as a persistent threat? And hopefully you hire someone who's advanced as well. Can we manage this? It helps us greatly because to me, pen testing has been like we're old dinosaurs. Slow moving, trying to provide value. While the criminals and the threat actors out there, they're agile, short-lived rabbits going everywhere, going sneaky here, sneaky there, trying to find vulnerabilities. It's like pen testing, we're playing badminton. Boop. Boop. And the professionals, the threat actors, are playing tennis. Bah! Ooh, super fast, right? Completely different sports. And this type of concept helps us bring back value to customers so that we can stop cyber threat criminals and so on, other types of threat actors. Is it hard to be a hacker? To me, you look at incident response, very often it is easy to be a hacker. It doesn't have to be very complicated. We can do better as pen testers and as red team and so on. It boils down to warfare. These two fighter jet pilots here fighting in a dogfight. In military training, they have a saying that the fighter jet pilot who has the quickest and most often OODA loops will win the battle. An OODA loop is the ability to observe, so observe our surroundings, detect the threat, orient ourselves. Is there mountains, is there missiles, is there weapon systems, and so on? Decide on an action and act on that action. The ones that do that the fastest and the quickest wins the battle. What about in cyber? We observe. We see log4j. Holy shit, log4j, everybody works overtime. Let's orient ourselves. How bad is this? It's really bad. Decide on a course of action. Do we tell our customers? Yeah, let's tell them preemptively. There's something big happening, and we're scanning their networks, trying to figure out if we can exploit them. If we find something that we've exploited, something we can weaponize into an exploit, get a callback or whatever, let the customers act on that finding where we prove that they can be hacked. If they can act before the criminals can complete their OODA loop, before they can weaponize their exploits and take over your server, if you can patch faster than that, then you won that battle. And there's another battle just around the corner. Tomorrow, there's another vulnerability, and another one, and another one. It's not getting easier. So OODA loops helps us. We should also strive to reach maturity and consider how we mature, essentially. If you're a common company these days, a normal company that haven't invested a lot in cybersecurity, you're probably on the scale of proactiveness and reactiveness, you're probably over here somewhere where you're blocking attacks with your EDRs, you bought some next generation firewalls perhaps, you got some preventive measures and so on, and if something bad happens, you're doing instant response, right? Then the CISO asks, all right, we just invested a lot in cybersecurity, are we there yet? And the CISO procures a penetration test. And after the pen test is done, they're like, yeah, we did it, boys. What's next? Where should we build? What should we invest in? And a lot of companies, they seek to build and invest into a security operations center. Managed detection and response, they're seeking to start to build that capability of looking at alerts and looking to see, is our defenses failing? Sitting with our spears inside a castle, waiting for somebody to breach the wall. That's what we're setting us up against, or setting us up for. What we're challenging with attack surface management and always-on pen testing is perhaps, in fact, it might be easier, cheaper, and higher value to, before you mature into SOC, or maybe at the same time, consider maturing into weaponizing and operationalize your pen test teams to work for a year at a time. Put those people to work every day and let them do attack surface management. Let them know you better than you know yourself. Let them know the attacker better than anyone else. You're going to win that battle. That's what we're challenging. Instead of waiting for some alert to come to say, hey, they found an exploit, let's clean up. We're saying, hey, let that alert tell the pen testers that, hey, there might be an exploit here. Check it out before anybody else can. That's what we're doing. And the next few slides are basically, I have almost 60 slides in this presentation, okay? I'm not going to go through them all. They are for you. I have uploaded the slides so that you can go over them afterwards for inspiration or ideas on how to build out your offensive security capabilities that allows your pen testers to do real-time work, agile, and so on. There are many different components that could be a part of an offensive SOC, and I'll talk about some of them. For example, public domains. Domains typically is the entry point for some kind of application, or it provides some kind of attack surface that we want to stimulate, or we want to target, we want to check it out, we want to scan it, we want to discover if there's any vulnerabilities there. We want to know if there's any outdated technology, or if the technology becomes outdated in the future. So when we are doing attack surface management, it very often revolves around domain information. And we can get a lot of domain information by being good hackers. We can, say, brute force their DNS servers, asking tons of questions using specialized word lists to see, can we get any more domains, any more attack surface? We can also become purple. We do this with cloud assets, and we can also do it with domain assets. We can mix blue and red. We can go to our customer, whom is our partner, right? They've hired us to do the best job possible. We can ask them, hey, why don't you guys just give us the zone transfer of the entire DNS server? Why don't you just give us all the results that you put in your DNS so that we know of every domain? That's cheating. We like to cheat. Cheating allows us to beat the real threat actors because we're emulating an adversary or a threat actor, but really, we can cheat and become a better threat actor for the benefit of our customers. Say in cloud assets, we deploy Lambda functions in AWS, we deploy functions as a service in Azure, and same thing in Google Cloud Compute, and we let those functions run twice a day, and it just collects the entire asset inventory of the target, and it gives it to the pen testers. Hey bros, you guys, you're with me, right? I know you're really dangerous and you're hackers and all of that stuff, but why don't you see what this gives you? Does this weaponize you at all? Does this give you any entry points to our businesses? We should cheat. Perhaps the most useful ever technique for hacking is looking for certificate transparency logs. When your operators, your developers, etc., when they deploy a domain, or in fact, when they create a certificate, the certificate authority must publish that certificate in a public log that is accessible by your browsers and anyone to read. That way, we can make sure and we can verify that, hey, these certificates that are being generated on our domains and so on, they're authentic, they're good. We approve of these certificates. It's a way to protect ourselves against malicious or compromised CAs and so on. But those CTL logs, they contain super useful information. For example, I searched up DefCamp while I was in the back of the room, and I searched this on a website called cert.sh. You can search for Google and Facebook, they have a similar functionality. And I asked, what kind of certificates have DefCamp created? And I figured out there's a latest DefCamp, there's an event admin DefCamp, there's an event API. Oh, this is where I want to break in. These are the systems that I want to find. I want to find the path least traveled to. I want to find the more interesting ones. And the CTL just shows me public information. Yes, a wildcard certificate would help you defend against this. The NSA does not recommend you to use a wildcard certificate. Either they know more than we do, and they have something nasty with wildcard certificates, or they don't want to lose this technique themselves. I don't know. But it's super useful. When we do attack surface management, we don't monitor for, say, def.camp. We don't monitor for our customer.com domain. We monitor for the customer's brand, DefCamp. And we look for defcamp.com, defcamp.site, whatever. Any mention of the customer's brand in these logs that are millions of certificates every day, any mention of the brand, we get an alert on. Sometimes we have hundreds of new domains that represent our customer's brand because their domain name by accident is a part of a random generated domain, or it's a part of something not interesting whatsoever. Lots of false positives. But every week or so, we see new domains being created that are set up to phish our customers. So all of a sudden, somebody sets up riversiecurity.-gdprsecurity.com something. That pops up on our radar. And if we can automatically score and assess that system, hey, this new system, River Security, blah, 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 do they use the same mail exchange as River Security does? Do they use the same name server? Does it look like River Security? Is the logo present on a website? Is there a website? And so on. All of a sudden, we can combat a lot of targeted phishing attacks, credential harvesting attacks, and so on. It becomes super, super useful. There's all kinds of ideas and possibilities out there. For example, URL shorteners. Me and a friend, we did a project on this. We took the archive teams, they have a team called URL team. We took their data, where basically their data is brute-forced URL shorteners. So they take bit.li and all those URL shortener services, and they brute-force the extensions behind them. They use word lists to find content, they use brute-force algorithms and so on, and they publish the results. And we found that super interesting. We took that research data and put it into Kibana and Elk, basically stored it in Elastic and visualized it with Kibana, and we start digging through all that data, looking for our customers. Looking to see, hey, is our customers represented in any URL shorteners? And sure enough, we found our customers, but we found so much more. Outside of the thousands of hotel reservations, airline tickets, and all kinds of things, we found hacks in progress, where an attacker is URL shortening an attack, sending to his friend for basically sharing an exploit with them. We find IT operators sharing backup files among the team members on public web servers. Hey, Bob, take a look at this zip file I put on the server over there, and it's URL shortened. And they don't delete the zip file afterwards. So the results of this you can find online. It's on a blog post at sans.org. But it was very fun and interesting to see how can we be more clever in discovering not only the provisioned attack surface our customers are deploying, but also anybody else who talks or mentions about our customers. We see a lot of this. Parked domains. When a domain is parked, so some of our customers, they buy hundreds of domains, right? And they just leave them there, parked so nobody else can steal them. What should you do as a pen tester? You should know if this changes tomorrow. Does this website become something tomorrow? Does the DNS change tomorrow? So you deploy, say, a website delta checker, a DNS delta checker, that you receive an alert when there might be some content here, because you want to be the first one in. In certificate transparency logs and doing this kinds of work, we have examples of stories on how our pen testers, first of all, have a lot of fun at work. It is really fun being agile and doing work continuously. But we have stories where, for example, one of my customers, they had deployed 2 new domains over in the US. Their service provider had been given these 2 new domains to set up voice over IP, Microsoft Teams integration, something. So they have a service provider that is currently using those 2 domains to set up a new service. All right, nice. The certificates, so obviously these services need HTTPS, so the certificate goes into the public log, and my team, they get push notifications. Hey, new domains, let's go. First one in, huh? Let's see if we can find some vulnerabilities. Let's hunt for some cool juice, some cool vulnerabilities. And we see a blank website. Nothing there yet. All right, website delta checker turned on. Blink, blink every 10 minutes, we check. Does this website update? No? All right, every 1 day does it update. In fact, after about a couple of hours, the website update, it now has a commercial off-the-shelf product. And it's asking for a login. All right, interesting. They're deploying some solution here. So once there's an application there, the pen testers follow their procedures. They start to do what we call content discovery. Brute forcing folders and file names, etc. See if there's anything interesting. And sure enough, after a few minutes, we find a folder called /logs. You open up /logs. Inside, there's an indexed list of every single log file the commercial off-the-shelf product has created. Wow, that's convenient. We click one of the log files. Inside the log file, turns out the product is logging credentials in plain text. We found within 24 hours the super admin password to the service provider and the admin provider of the IT administrator over in Texas, US. Within 24 hours. Was that hard? Was that advanced? No. But was it persistent? Absolutely, heck yeah. Absolutely persistence. And persistence tends to win. There are so many things we could talk about, but I really want to leave open for some questions. Network services, trackers, splash websites, and so on. You know, whenever you see this page here, as a pen tester, at least as an offensive person, you know there's something more. Nobody puts a web server online just to show this picture. What else is there? And one of the best pro tip bug bounty hunting tips I can ever give you is to utilize IAS short name scanning. There is a way to abuse the fact that your Microsoft servers support old legacy DOS syntax for file names, and we can brute force the names of files and folders. And we can discover that file that is, for example, here's the process. Here we are using a IAS short name scanner against a target website, and we have found something called M tilde1, okay? Then we'll brute force the next character, ME, met, and then we can brute force the extension. So metadata.zip, turns out it was metadata.zip, and inside that zip file we found gold. We found what we were looking for to prove value to the customers. Tech stacks and so on. Take a look at this, right? There are so many different things here we could spend a long time talking about, but I'm gonna leave this value for you to research on yourselves, okay? Social media, user accounts, leveraging brand, reverse image searching, and so on. I just want to give back some value. What I hope that we're going to do in the future, and think about more, is when we're in our castle trying to build high walls to protect ourselves, instead of sitting inside with spears, I want you to go out. Leave your castle. Defend forward. Go outside and find these bastards down here digging a tunnel into your castle. Go out and find that there are people poking holes in your castle. See that the there's no more crocodiles and the water has run out. Going out of the castle and defending forward continuously is really nice. It really supports the top 18 controls. What is control number 1 and 2? Inventory of assets and software. Pen testers should have that inventory. And it also supports other controls as well. Same thing with other core and principles. So I'm going to be done here in a second now. Basically, Sun Tzu said it the best. Know yourself. You can know yourself. Asset inventory. Know the enemy. Everybody can learn to hack. It's not necessarily hard. And you will not fear the results of 100 battles. It is really that easy. Not. Everything is easy sounding, but it's complex. Thank you, everybody. I don't want to take up any other speakers' time. I want to leave room for changing and so on, and perhaps even questions. So thank you very much for listening to me.
We can take a few questions. There's time for this. So
Nice.
Any questions in the audience? There's a question over there towards the back.
There's got to be questions like, how the hell do you scale this? How do you operate this? How does it work? Like, how do you prioritize? How do you have time? Do you ever sleep? I understand that you have gray hair now, yes, and so on. So let's hear it.
Hi, is this thing? Yeah, it's on. So in the beginning of your talk, you advocate for customers allowing you to run Lambda functions in their cloud environment
Yes.
to collect asset lists.
Yes.
How do you suggest that at the end of your relationship, the customer secure against the fact that you now have all of this information?
Great question, thank you very much. So those Lambda functions, it's our code, right? We wrote it, but we give the code to the customer to deploy in their own environment so that they can see what's being run and they can disable that Lambda function at any time they want to. They are the ones that give that Lambda function the security auditor role. They're the ones doing privilege management. They don't give us credentials. Basically, this Lambda function just twice a day, so it's an event-based Lambda function, twice a day on a timer, it posts a message to an API that we have online for the customer, sending us the data. So hopefully that answered your question.
I'm sorry. The question was, how do you secure against the fact that you now have the data that has gone to your API? And at the end of your relationship, they do what? Overhaul their entire structure?
So at the end of the relationship, we would have to delete the data, right? And also protect it, obviously. But in terms of protection, we could go into the architecture of customer segregation, no multi-tenancy, how it's deployed in different cloud environments and different VPCs and so on. So yeah, we definitely need to protect the information that we manage and so on.
I think he's asking how the customer secure against you.
Well, we're their best friends, right? Except we're trying to break into their environments. I have no churn on our customers yet. But okay, I'm sorry, I'm misunderstanding. At the end of the relationship, how we delete the data, or?
How can the customer trust that you don't keep it?
Contracts, I guess. Or maybe they can do what they did in Men in Black, right? Give us that little thing in front of the eyes and it goes beep, 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 and they wipe our minds. So how do you delete your pen test reports? You should, right? You don't want to let your customers get hacked when you get hacked. So after a month, we delete our pen test reports after we're done with them, but we do store KPIs and interesting information, but we don't store the findings. It gets deleted.
Right, thank you.
Hey, all good, man.
Are there any other questions? Okay, one more question up here at the front.
You'll also find me at the SAMS booth later with George. So I'll be around for a couple of hours before I'm going to go explore Bucharest.
I have a question, more administrative side of things here. So all the examples that you've provided so far, they rather show more reactive approach towards things when it comes to incident response. And I would like to ask, like, in the last 10 years or 5 years, how has it changed from reactive to proactive? What's the increase in percentage, let's say? And not necessarily big customers, because you mentioned that they are willing to go proactive, but maybe small and medium?
So this kind of service for us is typically for larger customers that realize that reactive is going to be very painful. And with CrowdStrike's beautiful report on the breakout times that the Russians are down to 20 minutes until they've compromised one asset and they pivoted away, they realize that they need to do more proactive measures. But it's typically reserved for companies that are in the thousands of employees, typically. Small, medium businesses, it just doesn't scale for us on this service because this is so you can get 80% on the way with automation, right? Automation, robot scanners, it gives us some value, but the value of a service like this comes from actually qualifying those vulnerabilities that your scanners have found. Are they really worth it? Is there false positives or not? Can I hack you, yes or no? And that requires human intelligence in interaction with the alerts. So it scales the best for larger customers, not small, medium businesses. Attack surface management does though, but when you put on always on pen testing, it's a lot of work.
Thank you so much. Let's